on section 1.3. We're going to start solving some equations. It's all nice review stuff, but never hurts to kind of go back over some of the basics. This is one of the biggest and most important things that you need to be able to do in order to survive any of the rest of the class. So when we're solving our equations, we're always getting things on different sides of the equal sign. We always have to do opposites. If we want to move something that's positive over here, we have to subtract it from both sides. That looks funny. So we're talking about isolating the variable. That means getting our x alone or our y alone, whatever it is we're solving for. Our undo actions, the opposite things, addition and subtraction are opposites, so they undo each other. Multiply and divide, squares and square roots, all those kinds of things. This is different than our order of operations. It's going actually opposite. We always want to move our plus or minus number first, and then second, you want to take care of dividing by anything that you need to, or multiplying if you have to. Alright, so some of our easier ones here, a little two-step equation. We're going to subtract our 6 from both sides here. 5 minus 6 gives us that -1. Then we have to divide by not just 8, but -8 on both sides. And the negatives cancel, both here and here, leaving us with x equal to our 1/8. And I know it's a fraction, but it's okay. It's just the answer. We just leave it alone. Now, when things are not that simple, they're not just little two-step equations, we've got to get a whole bunch of things simplified first. So like this one here. If I look at this side, 24, it's as simple as can be. It's just 24. But my left side is a mess. So what do we have to do first? A little distribution. We get that 6x. We get that -24. Next, we've got to collect some like terms over on this side. Now, whenever I'm doing something that's on the same side of the equal sign, we use the same signs. We're not going to do add 2 to both sides because they're not on both sides. It's just the left side. So 6 minus 2x gives us that 4x right here. We do not do opposite things when we're on the same side. So a good rule, to kind of think about these things, same side means you're going to do the same symbols, whatever it is that you're talking about. Opposite sides are going to do opposite addition and subtraction, or multiply and divide, whichever one it is. You're always doing opposite when you're going to the opposite side. So that's a good rule. This is one of the easiest things that people make the mistake of trying to add 2x here and getting an 8x. Now that it's down to your two-step equation here, we're just going to add the 24, divide by 4, doing our last couple of things, and get our x equals to 12. So, nothing too groundbreaking. Now, our last kind of strange situation that we end up with is when we have the variable on both sides of our equation. We first need to think about simplifying things. Here, that's as simple as it's going to get. We can't put the 3x and the 2 together. They are not like terms. But over on the right side, we definitely need to get some distribution done and change that into the 4x and the +24. At this point, when we start trying to decide which way we want to go with our x's, we know we need to get them together. We know we're going to do an opposite because they're on opposite sides. It is almost always going to be easier to move the one that is smaller. In this case, the 3 is smaller than the 4. It's going to be easier to subtract 3x from both sides because that leaves my x to be positive. And we'd always rather have our variable that we are trying to solve for, that we are trying to isolate, we'd always rather have that be positive than negative because it saves mistakes that we could make later. Is it the only way to do this? No, you could subtract the 4x and go that way, but it is going to be the easier way to do it. So we have to subtract our 24. Alright, so once we subtract 24 from both sides, we end up with our x equals the -26, and that's just one way to write your solution set that we probably will never use. The last major type of question that they're going to put on your semester exam is this one where we've got our things with fractions here. So what we have to do is multiply to get rid of all of these fractions on the bottom. So what our goal is we're going to try and make sure that everybody has the same fraction on the bottom, and then we can just forget about the fractions and solve the equation like we were doing all these other ones. So our least common multiple, that's the number that all of our bottom numbers here are going to multiply up into. So the smallest number that a 10, a 5, and a 3 all multiply to make would be 30. So we're going to multiply every single thing, even the 2x down here, by 30. What this is going to do is it's going to cancel out all the bottoms of our fractions. It'll make some of our numbers a little bit bigger, but it will make it where our fractions are gone and we can solve. So 30 divided by 5, when we cancel that out, it makes 6. So we're left with 6 times 3x makes the 18x here. We do the exact same thing with all the rest of them. 30 divided by 10 makes 3. 3 times 9 makes the 27. 30 divided by 3 is 10, and 10 times 1 just stays 10. Here we have nothing to cancel out because there was not anything on the bottom of the fraction, so 30 times 2x leaves us with 60x. At this point, it's the same kind of solving things that we've been doing all along. Subtract our 18x from both sides. Makes our 42x here. We're going to subtract 10. Gets our negative 37, and then divide by 42. And that answer is disgusting. But since it doesn't simplify, nothing goes into 37 and 42, we get to just leave it alone. Alright, so now on to the other types of examples. Alright, so working this one out, I like to write a line down here through my equal sign to kind of make sure I know where things are on the left side and the right side, and when we're doing to do the opposite symbols and when we are not. Common mistake here is we see a negative 5, so we think we need to add 5 to the other side, but we need to think about what it is doing to the n. It is multiplying the n, not subtracting. So since it's multiplying, the opposite of that is to divide. That's why we cancel that stuff out that way. Negatives are going to cancel here as well and leave us with just n equals 3. Alright, now on to our two-step equation. We're going to try and get r by itself, so I'm going to have to get that 12 out the way. Always want to do our add-subtract number first. Leaves me with 50 on this side, 10r on the left. Now we can divide by our 10, cancel that out, and r equals 5. Here, what do we need to take care of first? Hopefully you're talking about taking care of the parentheses and doing our distribution. So we've got to get the left side a little bit simpler and before we can start moving things around. So I'm going to distribute here. 6 times 3x is going to make 18x. 6 times 1 is minus 6, equal to our 24. So now we're ready to go on the rest of our steps now that we've taken care of the parenthesis group. I'm going to add 6 to both sides. It gives me, 30 there. Always rewriting the things that have not changed so that we do not lose those along the way. Divide both sides by our 18 so that x equals, 30 over 18. We're not going to just leave it like that. We're going to simplify it if we can. Is there anything that goes into both of those? I believe 6 does. 30 divided by 6 makes 5, and 18 divided by 6 makes 3. And again, we want to leave this as an improper fraction. We do not want to write 3 and 2/3 because that's just more work. And who wants to do more work if we don't have to? Alright, so what's going on here? My left side is simple. Don't need to do much. But on my right side. But my left side, it's got a whole bunch of things that we need to put together here. We've got to take care of our minus 2x and our minus 7x. Since they are on the same side, we are going to use these same signs. So we're going to put those together. Minus 2 and minus 7 make minus 9x. I'm going to rewrite everything else so I don't make a mistake along the way of losing one of my terms or making a mistake with one of those positives and negative signs. Now I want to get my x's together. There's one on the left and one on the right. The one that is going to be easier to move is always going to be that one that is smallest, and negative 9 is definitely smaller than positive 2, even though 9 itself as a number is bigger. You'd always rather have $2 than owe somebody 9. So I'm going to add 9x over to this side. That gives me 6 over on the left, 9, 10, 11x on the right. And lastly, we will divide by 11, so we get x equals 6 over 11. Now, most of the time in your life, when you're solving something and you get a weird fraction like that, you assume you did something wrong. That is not always going to be the case in here because numbers are going to be fractions from time to time. Alright, example 5. So here, don't worry about the crazy looking fraction going on here. If we just kind of forget that's there, what would we do to the 3? We would add 3 both sides, right? So just because there's a fraction there doesn't mean you need to freak out and assume that you're not going to be able to do the problem as a whole. Add 3 to both sides. So we got 1 over 7x equal to now 4. So think about opposites. With a fraction, the bottom number is just a divide number, so it's saying we're dividing by 7. What's the opposite of divide by 7 is to multiply by 7. That's how we cancel that out. But if we're going to do it on the left side, we've got to multiply on the right side as well. And 4 times 7 is 28 last time I checked. So that's our answer, and it's not as bad as it looks. This one is as bad as it looks because we've got a fraction in all three parts. But if we just relax, it might be okay. So what do we have to multiply our numerators by? What do we got to multiply by? What's the smallest number that 3, 2, and 6 all multiply up to make? Please don't say 12 because they all go into 6. 6 times 1 makes 6. 2 times 3 both make 6. So what we're going to do is we're going to multiply by 6 on all of these. Now 6 divided by 3 makes a 2, so we're really going to have 2 times 5 there. 6 divided by 2 makes a 3, so minus, don't forget that minus sign, minus 3x, and 6 divided by 6 goes away completely, equals 7. Well, 2 times 5 makes 10, so I got 10 minus 3x equals 7, and this problem got a whole lot easier. Let's subtract our 10 from both sides, get our negative 3x equals negative 3, divide by negative 3, and x equals 1. Not bad. You take that number that they all multiply up into, you cancel some stuff out, and life is not so bad. Example 7, though, is a mess. We've got all kinds of things here, but again, what's the number that 3, 6, and 3 all have in common? 6. So we're going to multiply everybody by a 6. Alright, let's pick a new color. 6 divided by 3 makes 2x. 6 divided by 1 doesn't do anything, so 6 times 2 makes 12. 6 divided by 6 goes away, I'm left with just x, and 6 divided by 3 is 2, so 2 times 4 makes 8. So here 6 divided by 3 was the 2, and the 2x is where we get that. Here it doesn't go away at all, so 6 times 2 makes 12. Now, this isn't really a bad problem. We're going to subtract my x from both sides, get x over on this side. I'm going to subtract 12 from both sides as well. Just do it all at once here. 8 minus 12 makes negative 4. And that's it. Once we get those fractions out the way, it is not a tough, scary problem. Alright, this is exactly what it's going to look like on your semester exam. This is the one they've used before, and hey, look at that. It's a 2, a 3, and a 6 again. So, put my 6 here, my 6 here, and my 6 here. We know that's going to cancel out and just leave my 5. 6 divided by 2 is 3. 3 times 1 makes 3. 6 divided by 3 is 2, and 2 times 2 makes 4x. So I got 4x plus 3 equals 5. Subtract my 3 on both sides, and divide by 4. And so x equals 1/2. It's an ugly looking 2 down there, but I think you get the idea. And hey, look at that. There's your quick, super fast review on how to solve all types of equations. That's all I got for you there, so we'll see you back in class. Make some good choices, and be safe.